So here we have our circuit. Let's look at the circuit. So we have this breadboard. This is the positive rail. This is the positive rail. Is the one end of the resistor is connected to the positive rail of the breadboard. Then the positive, like one end of the resistor is connected to the positive or the anode of the LED. Then the cathode of the LED is connected to here to the negative rail through a jumper wire. So what I want to do, I just want to put connect this switch to the circuit so I can turn on the LED light whenever I want. Now it's just work just like that, and it will stay on forever until I remove the battery. So what I'm going to do to incorporate this push button into that circuit. Okay, let's do that. Not doing much. Removing this jumper wire. My power supply is connected through the battery to the power supply rail of the breadboard. Then from the positive terminal of the positive rail, you connect the resistor to the positive of the LED or the anode of the LED. Then the cathode of the LED, I'm connecting a jumper wire to it. So I connected this jumper wire to the cathode of the LED. Let me see if I can zoom. Okay, there. Then I'm connecting the switch. One, it has like 2 pins. You can see it is. Okay, the one of the 2 pin I'm connecting to the jumper wire. Just here, like that. So connected one of the pin to the jumper wire, and the other pin of the switch connecting to the ground using this jumper wire, just like that. So if you look at the circuit, positive to the resistor, from resistor to the anode of the LED, then the cathode or the negative terminal of the LED to a jumper wire. Then other end of the jumper wire is connected to the push button. One leg and the other leg of the push button is connected to the ground or the negative terminal of the LED. They connected the battery there, just like that. Let's see if it works. Gonna try give it a push. LED is turning on whenever I push the button, and whenever I release my finger, it will turn off. So that is it. But now I'm gonna show you a little bit of calculation, a little bit of mathematics, just very simple, which is good to know. So the calculation is to find the value of this resistor, which is quite important because this blue LED is 3 volt. That's the working voltage of this LED, 3 volt. And it's 30 milliampere. That's the maximum allowed current through this LED. But the battery that I'm using is 9 volt. If I connect this LED directly to the battery, I discussed that in the previous video, it will burn out. So we use this current limiting resistor. But how do we find the value of this resistor? I'm using this 220 ohm, but how did I find, how do I know it is 220 ohm that I should be using? So that's this calculation about. This calculation is very simple. So we have the circuit here, we have 9 volt here, we have the resistor R, and we have our LED and the switch. So when the switch closes like that and the LED turn on, the maximum current flowing through the LED should be 30 milliampere. That's the manufacturer says. It shouldn't be more than 30 milliampere. It will damage the LED. And in order to get the 30 milliampere to flow through this LED, the voltage across the LED should be 3 volt. That's the rated voltage of the LED. That's like 3 volt. So we have 9 volt here. We have 3 volt across the LED. In order to flow 30 milliampere through the LED, we don't want anything more than 30 milliampere. So we have to drop. So we have 9 volt here, 3 volt here. The rest 6 volt should be dropped across this resistor R. That's like 6 volt. And we know the current flowing through the circuit should be 30 milliampere. So when we consider this resistor, the voltage should be 6 volt across the resistor, and we know the current flowing through LED should be 30 milliampere. Then we have to find the resistor the resistance. So there's a simple formula for that. That is, voltage is equal to current multiplied by resistance, which is Ohm's law. We know voltage is 6 volt, current is 30 milliampere, so which is milliampere, which is 0.030 ampere multiplied by the resistance. So I just converted the milliampere to ampere. So which means the resistance R is equal to 6 divided by 0.03, which is equal to 200 ohm resistance. So we got the value of this resistor should be 200 ohm. I think we can't get a 200 ohm resistor in the market. I'm not sure. But what I have here is a 220 ohm resistor. So the resistor is a little higher than 220 ohm, which is perfectly okay, which will limit the current or keep the current in the circuit below 30 milliampere. So it worked just fine. So I chose a 220 ohm resistor instead of 200 ohm resistor. So that's the circuit. I think it's a very easy one for the beginners to understand. So that's the circuit. And if you have any questions, just comment in the comment box. And if you learned something today, give me a thumbs up and subscribe to my channels so you guys can get more videos. I'll be making more videos, and that is it. Thanks for watching.